Let us continue. Okay, so now Ohm's law tells us that if a conductor is at a constant temperature, the current flowing through the conductor is directly proportional to the voltage across it. I hope it does make sense, because now we are talking about constant temperature, current directly proportional to voltage. Yes, this means that if we plot the voltage on the x-axis of a graph and the current on the y-axis of the graph, we will obtain a straight line. That is true. Why am I saying the straight line? Because we are saying that they are directly proportional, meaning when the voltage increases, the current will also what? The current will also increases. Now let's check. What is our voltage here? Our voltage here is 1. And then what is our current? Our current is also what? 1. What is our voltage here? My voltage here is what? Is 2. Meaning what is my current? My current is 2. What is my current here? My current is 3. What is my voltage here? My voltage is 3. What is my current here? My current is 4. What is my voltage here? My voltage here is what? Is 4. So that simply tells us that there is a relationship between current and what? And voltage. What is the relationship? Is that they are directly proportional. When the current increases, the voltage will also increases. The voltage will also increases. So my beautiful learners, when you are given the graph, and then our graph is between the current and the voltage, if the graph forms a straight line, we can say that this or whatever, or the conductor that is being used there is the one that follows what? Ohm's law. And then we regard it as what? Ohmic what? Conductor. We refer to as what? Ohmic what? Conductor. So let us check one other thing. On the y-axis, we have what? Current. On the y-axis, we have been given what? A current. And then on the x-axis, we have been given a what? A voltage. So when we determine the gradient of this graph is delta I all over delta V. For the fact that I is on top, V is at the bottom. I is on top, but V is at the bottom. Now let's check. We don't have the formula here whereby we are having I on top and V at the bottom. We don't have. We can check. Here we are having V over I, but here we are having what? We are having I over V. That simply tells us that this equation is still the same as R over 1 is equal to V over what? Over I. So if I want to make this equation, it shows that is the same as what? As 1 over R. Are we together? But if it happens that we change the axis, let me just make an example. If we change the axis, meaning on the right hand side or on the y-axis we have V, and then this side we have I. Obviously when we determine the gradient, we know that the gradient is change. Our gradient is changing y over changing what? In x. So our y now is what? Our y now is V, and then our our x now is what? Is I. So what is V over I? V over I, it has to be what? R. So please, my beautiful learners, please be aware. If you are given a graph And then on the y-axis of the graph, you have been given the current. And then on the x-axis, you have been given the what? The voltage. Know that the gradient of that graph, represent the inverse. It represents the inverse of resistance. But if you are given V, which is our potential difference or our voltage on the y-axis, and then you are also given the current on the x-axis, the gradient of that graph represent what we call what? The resistance. The gradient of that graph represent what? The resistance. Because now let's check. The gradient of a straight line is related to resistance of what? Of the conductor. As you can see that I over V, which is this one, I over V is equals 1 over R. Even if you want to rearrange this equation, we can say that we can cross multiply here. And then we have V multiplied by 1 is V. Is equals to I multiplied by R is I R. This one is one of the formula of what? Of Ohm's law. Or if I want to make R subject of the formula, I can just say V is equals to IR. I divide both sides by what? By I, and then I cancel R, and then we have R is equals to V over what? V over I. So please make sure that you practice this one as well. My beautiful learners, one other thing is that we have two types of conductors. We have ohmic conductors. We also have non-ohmic what? Conductors. When we talk about ohmic conductors, we are talking about the conductors that obeys Ohm's law. We talk about the conductors that keeps the temperature constant. These are the ones whereby even when the voltage increases, the current will increase, provided that the resistance of that the resistance will remain the same, or the temperature of that resistance will do what? Will remain what? The same. So, but when you are talking about the non-ohmic conductors, these one are not the one that are not obeying Ohm's law, meaning are the ones whereby we are going to see the temperature changes. Okay, now let's check. Let me just go through it. Conductors which obeys Ohm's law have a constant what? Resistance. When the voltage varied across them or the current through them is increased, these conductors are called ohmic conductors. A graph of current versus the voltage across the conductor will be straight line, meaning for ohmic conductors, this is what we are going to see. If I have V and then I have I, the graph is going to be this straight. This conductor, remember that this one, we are saying that the gradient represents what? The resistance. You know? The resistance that is being used here, we can say that is a conductor. For the fact that it gives us a straight line, we can conclude by saying that this one is a what? Is a ohmic conductor. Why? Because the relationship remains. That V is directly proportional to what? To I. And then the lines that is being formed here, it forms a what? A straight line. Okay, let me repeat it. Conductors which obeys Ohm's law have a constant resistance. When the voltage is increased, when the voltage varied across them or the current through them is increased, these conductors are called ohmic conductors. A graph of current versus the voltage across these conductors will be a straight line. Some example of ohmic conductors are resistors, and the nichrome wire. Okay. As we have seen, there is a mention of constant temperature when we talk about Ohm's law. This is because the resistance of some conductors changes as the temperature changes. Yes, let me underline it. This is because the resistance of some conductors changes as the temperature changes. This type of conductors that changes with temperature are called non-ohmic conductors. Non-ohmic conductors, because they do not obey Ohm's law. They do not obey what? Ohm's law. A light bulb is a common example of non-ohmic conductor. Light bulb is a common example of what? Of a non-ohmic conductor. Other example of non-ohmic conductor are diodes and transistors. So let me talk about the light bulb. My beautiful learners, when you go to shop and then you buy the light bulb, 60 watts bulb or 100 watts bulb, and then you put it on, and then you switch the bulb on maybe for 5 hours. When you go to that bulb and then you touch it, it will be hot. That simply tells us that the temperature of the filaments, it keeps on what? It keeps on changing. Because of initially when you put that bulb on or in, it was very cold. But after a certain period of time, when you go to it and then you touch it, it is warm. So it shows that the resistance of that bulb is not, the temperature keeps on what? The temperature keeps on what? On changing. So that simply means even the resistance, it changes, because remember what I said? I said that the temperature is one of the factors that affected the resistance. That is why when we are talking about the non-ohmic conductors, we are going to see something like this. Maybe I will be having a V here and then I on the x-axis. The graph will be like this. So when we come across something like this, it shows us that now V, it was directly proportional to I for a certain period of time, but after this the relationship changed. I can say maybe our I, maybe it was constant, but our V kept on what? On increasing, or the other way around. So this one, it shows that the relationship between V and I, or our graph, is not forming a straight line. There is a difference between graph A and graph B. For graph BA, our resistance, it was what? Constant throughout. But for graph B, our graph, there was a point whereby it changes the direction. So it shows that this one is a conductor that do not obey Ohm's law. So for this one, we are referring to as the ohmic conductor. But for this one, we are saying this one is is a non-ohmic conductor. Yes. So now let's check. In a light bulb, the resistance of the filament wire will increase dramatically as it warms from the room temperature or to operating temperature. So let me repeat it. In a light bulb, the resistance of the filament will increase dramatically as it warms from the room temperature to operating temperature. If we increase the supply voltage in the real lamp circuit, the resulting increase in current causes the filament to increase in temperature, which increases the resistance. So meaning this tells us that the resistance of the filament, if the temperature, if we increase the voltage, obviously the current will increase. And then if the current increases in this situation, the temperature will increase. And then if the temperature increases, the resistance of the resistance of the filament will also increase. So meaning this one does not obey Ohm's law. Why am I saying this? Let's check. If we increase the supply voltage in a real lamp circuit, there will be an increase again in what? In current. That causes the filament to increase in what? In temperature, which increases the what? Increases the resistance. Now let's check. V, it increases. Current, it increases. Remember in Ohm's law, R, it must be constant. But now check. They are saying that the temperature is also going to do what? To increase. That will result in increasing the what? The R. Can you see? Our voltage increase. Please write it in full, my beautiful learners. Our voltage increases, and then our current increases. That is according to Ohm's law. But our R, it must be constant. But in this situation, our R is also what? Increases. So that simply tells us that this resistor or the light bulbs, it is not a good example of what? Of Ohm's law or of ohmic conductor. Why? Because of the bulbs, the resistance of the bulbs or the filament, it does not remain what? The same, but it keeps on changing. If V increases, the I increases, even the temperature will increase. That will result in R doing what? In R increasing. So that is that. So meaning this one does not obey Ohm's law. That is why we are referring to as what? As a non-ohmic what? Conductor. This effectively limits the increase in current. In case voltage and this effectively limits the increase in current. In this case, the voltage and current do not obey what? Ohm's law. I hope you understand it, my beautiful learners. I hope you understand it. So please make sure that you visit your examination guideline so that you can check the definitions of the terms the way they are supposed to be answered, and then even the Ohm's law, it is there. And then please make sure that you search more information, or you do your research about ohmic and non-ohmic what? Conductors. So from my side, I thank you. See you next time.